All right, so this is introduction to optimization. So basically, optimization is the application of maximums and minimums, the first derivative test. Okay, so if you remember, to find the maximum or minimum value of a function, you have your function written in terms of one variable. You do the first derivative test to find your critical points. First derivative test means you take the derivative, set it equal to 0. You do your line test to find where your derivative is positive and negative. That'll give you your critical points and tell you whether or not they're maximums, minimums, or neither. And then, of course, you check your endpoints if necessary. Okay, so our guidelines that we're going to be looking at for solving applied minimum and maximum problems, which is optimization, okay, is that you need to identify all your given qualities and quantities to be determined. Possible, make a sketch. So if it's a scenario that you're dealing with, make sure you sketch it out if possible. You write your primary equation. That is a quantity that you're going to maximize or minimize. Okay, then you reduce the primary equation to a single variable, and that's usually using your secondary equation. Now, your secondary equation is basically like your limiting factor. It's the other piece of information that you need. Okay, generally in real world problems, you're talking about like materials, space, the amount of volume. Okay, and that's what usually gets your primary equation down to one variable. Okay, then you determine feasible domain of the primary equation. So you look at possible x values. For instance, if you're trying to like maximize area, obviously your length and your width aren't going to be 0. That's not going to be included in your domain, because if you have a length of 0, of course you don't have area. So you got to think about possible domains. Okay, and then determine if the desired maximum or minimum value by doing your first derivative test. Okay, so it's really, really straightforward. So let's look at just a really easy example. Okay, so find two non-negative real numbers whose sum is 23 and has the largest, supposed to be product, possible. Okay, so I'm going to pick x for my first number and y for my second number. Okay, just to keep it simple. I could use n1 or n2 or any kind of other variable if I wanted to. Okay, so what are we trying to optimize? Okay, we're trying to find the largest product possible. Okay, so product is what we are trying to maximize, and the product of this is x times y. Okay, that is what we are trying to maximize. We're trying to find the largest product possible. Okay, now what's my secondary equation? What's my limiting factor? Well, what's limiting my product, I mean, I could use 100 times 100, right? Or 100 times 200. But what's limiting me is the fact that their sum has to equal 23. So my secondary equation is x plus y has to equal 23. Okay? So these two equations fit together. Okay, so I'm trying to maximize my product. So basically, I'm going to take the derivative of it. But since I have two variables, what we're going to do is we're going to use our secondary equation, this sum equation, to actually get our primary equation into terms of one variable. Okay, so I'm going to solve for y. Okay, which is what we normally do. So y is 23 minus x, which makes sense because whatever x is, whatever I pick for x, y will be 23 minus that. Okay, so if I say, hey, x is 10, that means y is 13. Okay, so I'm going to rewrite my primary. So I'm going to say product equals x times, and now y is 23 minus x. So now my primary equation is in terms of one variable. So I'm going to simplify. So my product is 23x minus x squared. Okay. Now that I have in terms of one variable, now I'm going to optimize it. I'm going to find the maximums or minimums. Well, How do you find the maximums and minimums of a function? You take the derivative. So p prime equals 23 minus 2x. And then once you have the derivative, you set it equal to 0, which means that you solve for x. So you get 2x equals 23, and x equals 11.5. 23 divided by 2. Well, that means that what's going to maximize my product is when x is 11.5. Well, that's great. We know what x is. That is 11.5. Well, what is y? Well, then we use this equation right here to find y. So 23 minus 11.5, which is 11.5. So the two numbers that if we want to add up to 23 but gives me the largest product possible is 11.5 and 11.5. Okay? That's how this works. Find your primary equation, which you're looking to optimize. You find your secondary equation or your limiting factor, what's keeping that from being as big as possible or as small as possible. You use the secondary equation, you plug it in, get it into terms of one variable, take your derivative, set it equal to 0, and then that'll give us our numbers. Now notice I didn't do a first derivative test for this one. I only had one value, so technically I didn't have to do a first derivative test. But if you had, you would have seen very easily if I had put in right here my 11.5, that is my 0, and if I had put in, say, 0, I would have gotten a positive number, and if I put it in, say, 12, I would have gotten a negative, so my function goes from increasing to decreasing. So this is, in fact, a maximum. And again, if I was looking at my domain for this, the possible domain for this function would be between 0, x would have to be between 0 and 23. Not equal to 0 or 23, because if x is 0, we wouldn't have a product, it would be 0, and if it were 23, that means y would have been 0, and then we still wouldn't have had a product. So that's what they mean by your domain. Okay? And I'll work example number 2 in a separate video.